Hello and welcome back. For this video, we're going to be discussing lesson 4.1, which is graphing linear functions. You'll see today's goal is to graph linear functions by making table of values and graph linear functions by using x and y intercepts. So you have to remember those from the previous unit or previous module. For the learn portion here, it tells us that a table of values can be made to graph a linear equation. Every ordered pair that makes the equation true is a point that's on the graph. So what does that mean? The graph represents all possible solutions to the equation. For example 1, we want to graph by making a table. So here is our linear equation, and we can tell that it's linear because the y value has a power of 1 and the x value has a power of 1, and that's what makes it linear. When we make a table of values, we make a table like you see over here on the right hand side. We take this portion of it, which is the independent side. We're going to write it up here, and we're going to take any amount of x values that we want. In this case, they give us which x values to use, and we're going to substitute in and then calculate the y value. So the first one would be -2, and in parentheses, -4 minus 3. In order to calculate the y value, you have to know your order of operations. So -2 times 4, -4 is first. That would give us 8. 8 minus 3 is going to give us 5. And what that means is the point -4, 5 is a solution to the equation, but it's also on the graph of the equation. For the next one, we're going to put a -2 times the input of -2 minus 3. That will give us a 4 minus 3, which is 1. And we have -2, 1. Then we're going to put a 0 in there. And -2 times 0 is 0, minus 3 is -3. So the point 0, -3, and that should look familiar. That is the y-intercept. We'll do the same thing with the 1, so input a 1. -2 times 1 is -2, minus 3 is -5. So we have 1, -5 on the graph. And again with the 3, so -2 times 3 minus 3. That will give us -6 minus 3, which is -9, so the point 3, -9 is on the graph. You'll notice all these numbers here and all these numbers here are the same. The only thing that's different are the numbers in the middle here. Those are the input values which come from the independent or the domain values of x. The values on the right hand side, these y values, are calculated. You don't choose those, you calculate those. And then everything else on this right hand side is a solution of the system. All right, so the next thing we're supposed to do is go graph those points. You'll see the points are here, 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 and here. And those just represent 4 points. I think there were 5. Those represent 4 possible points. However, everything along this line has an x and a y that makes our equation at the beginning true. So the line is the representation of all possible solutions of a 2-variable equation. So our linear functions are 2-variable equations. That should be equations. There we go. Go ahead and pause the video and attempt the check. Okay, for this one, we're going to input a -5, and each of these x values here are going to go in here. We're going to calculate them one at a time. So we have 2 times -5 is -10. -10 plus 5 is going to give us -5. So we're going to go graph that. -5, -5. And you got to pay attention to your graph here. It is not going, the scale on this is not by 1s, it's going by 2. So -5, -5 would be right about there. And then we're going to put a -3 in. So we did the -5. Now we're going to put a -3 in and see what the output is. So put a -3 in. -3 times 2 is -6. -6 plus 5 is -1. So again, we're going to plot -3, -1 on the graph. So -3, -1 would be right about there. Do it again with the -1. So 2 times -1 is -2. -2 plus 5 is 3. So we're going to plot -1, 3. So -1 and +3 would be right about here. Put a 0 in there. 0 times 2 is 0. 0 plus 5 is 5. So we have 0, 5. And that would be right about there. And then 2 times 2 is 4, plus 5 is 9. So 2, 9 is the next one. 2 and 9 it appears to be right about, looks like right about there. When you're done with your points, draw the best straight line you can through this. And keep in mind that this line goes on forever, so we should put arrowheads at the end of it like that, because that represents every possible solution to this equation. For example 2, we're going to do the same thing, only choose an appropriate domain values. All right, so if we look at our equation, you'll notice we have this fractional value out in front of x. So that denominator of 4 means we're eventually going to divide by 4. So when we start choosing domain values of x, we want to choose values that are compatible through division with 4. And you'll take a look at our x values they gave us. You notice each one of those is going to be evenly divisible by 4, including the 0. So when you go to do this, you want to always take a look at your coefficient before you start deciding on what x's you're going to use. Even if I had it written like this as x over 4, that is still equivalent to 1 over 4 times x over 1, which is 1/4 times x. So even if it's written this way, I'm still multiplying by 1/4, or my coefficient is 1/4, which means I'll eventually be dividing by 4. So let's go ahead and calculate this. So 1/4 times -8 plus 3. 1/4 times -4 plus 3. 1/4 times 0 plus 3. And 1/4 times 4 plus 3. And 1/4 times 8 plus 3. So go back to the top one. So 1/4 of -8 is -8 divided by 4, which would be -2. -2 plus 3 is 1. So the ordered pair there would be -8, 1. The next one down, -4 times 1/4, or -4 divided by 4 is -1. -1 plus 3 is 2. So we have -4, 2. So our numbers come out nice and neat. That's why we're choosing these compatible numbers here. 0 times a fourth is 0. 0 plus 3 is 3. So we have the y-intercept there of 0, 3. So that's the y-int. So as you do this, you might want to point that stuff out. 1/4 times 4 is 4 divided by 4 is 1 times 1 plus 3 is going to give you 4. So we have the 0.44. And then again, 8 divided by 4 is 2 times 1 is 2. 2 plus 3 is 5, so we have the 0.85 on our graph. So the second part here is to go ahead and graph your points. So the first point was -8, 1. So -8, 1 is going to be right about here. The next one was -4, 2. So -4 and 2 is right here. 0 and 3 right about here. And it looks like we're doing this right because all these dots appear to be in a straight line. Then we had 4 and 4, which would be right about here. And the last one was 8, 5. So 8 and then 5 would be right about here. And then you're just going to do your best to draw as straight a line through those points as possible. And don't forget to put little arrowheads at the end, because the line does go on forever. And remember, that line represents all possible solutions to the equation. If you're taking notes in your foldable, you might want to go ahead and write this down. The line represents all possible solutions to the equation. Go ahead and pause the video and attempt to check. Okay, for this one, we have a coefficient of 3/5 that's going to multiply by each domain, or each x value. I'm going to show you how to do that off the side for the first one. So the first one, we're going to put a -10 in, so 3/5 times -10. And then eventually we're going to subtract 3, but I want to show you how to deal with this right here. So you take the -10, and you first divide it by the denominator. So -10 divided by 5 is -2. Then you take this remaining -2 and multiply it by the numerator, because every fraction is a division by the denominator and a multiplication by the numerator. So we end up getting a -6 out of that. And then -6 minus 2 is going to be -8. Go graph that point, -10, -8. So negative 10 is at the very end, negative 8 is right about here. Then we'll do it with the negative 5. So negative 5 divided by 5 is negative 1. Negative 1 times the 3 in the numerator is negative 3. Negative 3 minus 2 is negative 5. So we have negative 5. So left 5, down 5 would be right about in the middle of this box. Now we'll do it with the 0. 3/5 times 0 is just 0. 0 minus 2 is negative 2. So 0, negative 2 would be right about here. We'll put a 5 in there now. So 5 divided by 5 is 1. 1 times 3 is 3. 3 minus 2 is 1. So we have an output of 1. So 5 and 1. So over to the right 5, up 1 is right about here. And then we'll put a 10 in there. And 10 divided by 5 is 2. 2 times 3 is 6. 6 minus 2 is 4. So we have a 10 and a 4, which would be right about there. Last step is to just draw the best straight line through those points that you can. And don't forget to put arrowheads at the end of your line. For example 3, they want us to graph y equals a. In other words, there's no x value in the problem. Now, what you might want to write down in your foldable, if you have it, and this is actually a repeat of something we've already stated, if we have y equal to a constant, then this is going to create a horizontal line. A little bit of a note there, so y equals a constant. Now, if they want us to graph it, you can write this, since horizontal lines are actual functions, you can actually write this as a function by putting a 0 in front of x, because if you remember, the identity rule of addition is adding 0. So even if I put a 0 in front of x and add it to the problem, 0 times x is 0, and 0 plus 5 is still going to give you 5. So the first one is just going to be 0 times negative 2 plus 5, which is just going to output a 5. And then 0 times negative 1 plus 5, which is still going to output a 5, because we end up with a 0 plus 5 every time. So 0 times 0 plus 5 is 5, and 0 times 1 plus 5 is 5, and 0 times 2 plus 5 equals 5. And what you'll notice on each of these problems is the y value is always the same. So anytime you have a constant value equal to a number, y equal to a constant, then you'll have a horizontal line in which the value of y does not change. So we get 0, 5. Now when we go to graph this thing, since y is constantly equaling 5, we're just going to create a horizontal line that always goes through y value 5, and don't forget to put arrowheads on your line. And there's the solution. Example 4, we're graphing x equals a, or x equals a constant. So for your foldable, when x equals a constant, we're drawing a vertical line. And that vertical line is going to go through the x-axis at whatever the value of a happens to be. So in our graph here, we have x equals negative 2. Now, since the vertical lines are not actual functions, we can't put them in a function table and come up with values. All it's saying is if we come up with some points on the graph, let's say I have 3 points here, this negative 2 means each of the x-coordinates has to be negative 2. So if I put some points in there, let's say 0, 2, and let's go with 6, if it'll fit on the graph, and I go and graph those, you'll see that they actually create a vertical line at negative 2. So I'm going to go and graph those. So we had negative 2, 0, negative 2, 2, and my negative 2, 6 would be up here off the top of the graph. It doesn't fit, but you get the idea that it should be a vertical line. And again, don't forget to put on arrowheads. Go ahead and pause the video and attempt to check. Okay, for this one we have x equals a constant, which means we're creating a vertical line. And that vertical line is going to happen at x equals 6. So we just count them out, 1, 2, 3, 4, 5, 6. So right here we're going to draw a vertical line. And every point along that line has an x value of 6, and it represents our solution. For the next portion here, we're going to graph using intercepts. And one thing you might want to write down in your foldables, if you have them, is that the x-intercept occurs when the value of y is 0. So the x-intercept is some value of x comma y. And the y-intercept occurs when you have a 0 in for x and you get some y value out of the problem. So this is very important to know because we're going to substitute values in for x and y And since we're using intercepts, what we're going to substitute is a 0 for either x or y, depending on which one we're asked to find. Okay, for this next example, we're going to graph using the intercept. So on the left-hand side, I'm going to solve for the x-int, x-intercept. And on the right one, I'm going to solve for the y-intercept, the y-int. Now remember, the x-int occurs when you have a 0 in for the y value. So we're going to place a 0 in for y and solve for x. So we have negative x plus, now this right here gives us 0 equals 8. When I have a plus 0, that's an identity. So what I really have here is negative x equals 8. And then to get rid of this negative sign, we're going to multiply both sides of the problem by a negative 1. So multiply by negative 1. So we have a negative 1 times negative x, which is x, and 8 times negative 1, which is negative 8. So the x-intercept is negative 8, comma 0. And we'll go graph that. The y-intercept occurs when we have a 0 in place of x. So we're going to put a 0 in place of x. And negative times 0 is still 0. And 0 plus 2y is an identity. So that's just 2y equals 8. Divide both sides by 2, y equals 4. So the y-intercept should be 0, 4. And we'll go graph that and then draw our line. Okay, so our x-intercept was negative 8, 0, which is here. And our y-intercept was 0, 4, which is here. And it only takes 2 points to draw a straight line, but since there's such a great distance there, it's best to use a ruler, but I don't have one, so I'm just going to try and eyeball this the best that I can. And one thing you don't want to forget is to put arrowheads at the end of your line. And that's your solution of graphing using intercepts only. Go ahead and pause the video and attempt the check here. Okay, for this one, to find the x-intercept, we're going to substitute in a 0 for y. So if I put a 0 right here for 4, for y, 0 times 4 is 0, and then I got to solve for x. So I'm going to subtract 36 from both sides, so I have a negative 36 equals negative 12x. Divide both sides by negative 12, and I will end up having 3 is equal to x, or x equals 3, so my x-intercept should be 3. And the y-intercept occurs when you put a 0 in for x. So we'll do it again, only we're going to put a 0 in for x right here. So we end up with 4y equals, now when I put a 0 in here, 0 times negative 12 is 0, and 0 plus 36 is just 36. And then keep solving for y, so divide both sides by 4, and y ends up equaling 9, so 0, 9. So go ahead and graph those. 0, 3, or 3, 0 would be right about here, and 0, 9 would be, looks like right about here. And then draw your straight line through it. Make sure you go all the way across the graph and add your arrowhead.